introduce myself. If it's okay, you can see my screen now with Aquasizer and Fluid, and you can hear me as well.
Yes, we can.
Well, this is a bit of what I want to talk about, a bit about myself, the Fluid project, a bit about field recording, face vocoders, and the Aquasizer I programmed. So let's first tell a bit about myself. I studied composition, orchestral, electronic, computer music, sound registration, and I've done many different things in life and sound. This is a picture of a setup in my studio. And now I will show a video of a performance with something a concept I've invented for live animation with the theater group Hotel Modern. And it's called The Great War. So let's see.
Has also brought in an award-winning performance called Great War. This live animation theatre is an artistic trend that is fast catching on in Europe, and it's performed by the multidisciplinary theatre group Hotel Modern here. Paul Force with his preview.
The Great War tells the story of the First World War. In one scene, puppet soldiers are bombed in a soil pit. This is filmed live and projected on a large screen. This way, the audience can watch the movie and at the same time experience the making of the movie. And critics say the production is striking for the contrast it draws between the tiny scale of the performance and the enormity of the events it represents. More than 50 instruments are also used in this performance by one sound artist to create the sounds of battlefields, machine guns, and even growing trees. Take these coconuts, for example. They're used to mimic the sounds of a horse's hooves.
When you have a tank, for instance, I use a vibrator and I put it on a tin can with marbles inside. And I do a coconut on top of it. So that gives the idea of sitting in a tank.
The Great War is the production's first foray in Asia.
Well, that's really funny. Very, very old equipment, and the vibrator was explicitly asked for, of course. Another project I did is with the game of life, and it is the building of a wavefield synthesis speaker system. The system is mobile, so the concert can come to you instead of you going to the concert. And, well, I can show a short movie with how it sounds and what it looks like. It's a video I've found on the internet. It moves a lot, but okay, let's move on to the project. Well, the project Fluid is actually part of a bigger project I'm working on. It's about the place where I lived, which is a quarantine station. There is a lot of history in this place, Second World War and stuff like that. Only artists live here, and that might end in 2 years. It's in the middle of the harbor of Rotterdam, which is quite big, something like 40 kilometers long or something. And this beach you see is next to my house. So the project is about the surroundings as well. So I have a sort of concept like earth, fire, water, and air. And, Fluid is the watery part. And the idea was to make 2 tracks with loops as if it were waves. And I thought of frequency bands that would move fluidly over each other. And so I decided to build a phase vocoder because this allows you to make very tight bandpass filters. And this became the Aquasizer. I started with field recording. Here you can see the setup, which sounds like this. Well, and the idea was to get a feeling as if you were standing in the water and your head is just above water level. So I used hydrophones. Here you see the JRF hydrophones. I've also used an ambient hydrophone, which is very nice and very high quality. Then for the middle of the recording, I used an MS system. Well, if you have questions about that, you can ask me later. As well as a Sennheiser ORTF system, which has a bit of a hole in the middle, so that's why I use the MS mic as well. To put all these center mics together, I use a system with Cardellini clamps and C-stands, which is a whole subject in itself. And for the outriggers, as they call it, it's the white AB system. I also used Sennheiser MKH microphones, also because these mics work with a kind of RF frequency modulation system, so they work very good in moist environments. Well, you see the windshields and the windjammers. That's because of the wind you have next to the river, which is always more than in the city. So this is what that looks like. Well, after you have recorded those sounds, you end up with 8 channels, and you will really have to think about time alignment and phase. So for this, I used a few plugins, Foxengo Sound Delay, where you can do sample delays, so you can very precisely match the time differences between the microphones. And I use this MAT plugin because it can show the phase between the mics in different frequency bands. Well, 0 phase is mono, negative phase is anti-phase, which you don't want. So you want to end somewhere in the low regions above 0, and then you get a very spatial sound. Cool. Well, here you see me standing in the water, rigging a mic. So then the next thing was building a phase vocoder. And actually a phase vocoder has nothing to do with vocoders. Well, anyway, not much. Phase vocoder analyzes amplitude and phase, and derivative of phase is frequency. There have been many famous and not so famous effects with phase vocoders. The first thing was pitch shifting and time stretching, which was the first things that were used, that it was used for. There are some books you can read if you want to know more about it, and especially some Max websites and a Max article that can make you go a bit deeper. But I found there are some errors in these articles, so I will explain something about that. Cool, this is the interface in Max. Actually, I've also built a Max for Live plugin since I was gonna record it using Live. So the most important part actually of this phase vocoder, since the phase vocoder on its own is not so special, but this phase vocoder has 8 frequency bands. That was where my idea started, with having 8 fluid frequency bands. So this means that every single band can have a different effect. So you can time stretch, a next band can pitch shift, another band can do randomization, and a different band can have LFOs over it. So the other thing is that every band can also, or the bands altogether can also be modulated. So I have made a video of this, since the patch is so heavy that it was a bit dangerous to do it live. And in this video, you can sort of, well, you can hear a loop of something else I made, and you can hear the frequency bands changing. Well, one of the things I should have said before actually is that one band is frozen, and because of these different bands, you can change the frequencies of the bands that are frozen. You can also modulate the frequency of the band. So actually you can sort of put an LFO on a frozen sound. So in the end, you don't hear anything of the frozen sound anymore. One of the things I found after programming is that you want to sort of map the frequencies more to the human hearing. So I built something that makes this series go from linear to exponential or logarithmic. Well, that looks something like that. Well, as I said, you can also put LFOs on the frequency bands. Well, anything inside Maximus P, you can ask about that in the breakout rooms, since there is a lot of stuff in there. Another important part of my plan was to make presets of all the different sounds and to let the sounds flow from one preset to the next. So there is a better storage system, which I wanted to use in live, but then I found out the processing is so heavy that it was impossible to record. So the final two pieces are like 25 minutes in total, but it took live 7 hours to render out the whole composition, which was a first time for me, not for video people, but yeah, it was quite heavy. The other thing I did was feed different parts of the recording I made, which was like something like 1.5 hours. I put different parts in a poly buffer, so I can also send different recordings to the phase vocoder. Then, because I wanted everything to loop, I also built a kind of metro and loop transport system. It locks to the tempo, and you can set the note values, and then it will trigger the sample from the start every next loop. So then this goes into the FFT, where the audio is played, and this is where I found that there is an error in most of the examples of working with PFFT and FFT in Max. And that is, they just put the count directly into sample and hold. But sample and hold, the old version, only started to sample if it moved from the initial value, which is 0, to a value above it. So that means it always skipped the first bin and took the first bin of the previous sample. That was easy to fix, and I noted this to Cycling 74, and then David Ciccarelli implemented several kinds of new triggering modes for the sample and hold thing. So if you build FFTs on the base of all the examples, this help file is something to look at. Then there is, of course, the standard possibility of changing the speed and the transposition of the face vocoder. And I've also made a video of this, but I think since I'm already talking for 15 minutes, I will skip that. Here you have something of the inside of the whole thing. The next part that is important with FFT and is mostly used when the sound is frozen, because that will sound very uninteresting and mechanic. They put in some phase randomization. And I've also put in location, so it can skip through the sample, so it's not playing linearly anymore. And I can also do it with non-frozen samples. So, and that also is different for every single channel. I will also skip this video. Well, then here we have the inside of the FFT and the PFFT. Here you can see one band, but there are 8 bands, which is why this processing is quite heavy. Because to do this LFO thing inside an FFT, which is a bit crazy because a FFT always takes bins, so parts of a sound with a certain length. So you are actually jumping through LFOs, and you can only do it if you do that in the full spectrum mode. So actually part of that is not done with FFTs, but that comes after this. The next, and that is also a very important part of this whole thing, is the mixer, because the mixer has mute and solo, but more than that, you can also mute or automate the mutes and solos. And with the ADSRs, it is possible to shape the sound. The ADSRs are, I think, actually the problem why it took 7 hours to render this whole stuff, because I made a video and it's not even possible to move from one preset to the next. So I just skip it, but I'll let you hear the result. So you can hear that using the LFOs, it actually becomes a synthesizer where you can shape all the sounds you make. And at the start, you could hear me soloing channels. So that could be interesting to just use a few bands. Bands can also overlap. So what you can actually do, if you have one sound in 2 different bands that overlapped, you can even transpose a sound to make it like a kind of multiphonic instead of monophonic. Well, the mixer window has a lot of JavaScript behind it for making the solo and mute buttons, and also for integrating this with the pattern storage, which I will skip through very fast now. And then another thing I did was to have a sort of counterpoint to this always changing phase vocoder. I wanted to have long cycles of repeating samples. I also made with the phase vocoder, but then just playing with the push tool and some other controllers. And to split the samples, there is something very handy, which is now integrated into Max MSP, which is called Flucoma. And Tom Hall built a patch for Richard Devine, which actually splits sound files by recognizing that there is something different going on. So you can see all the numbered buttons on the right top, which are the samples I selected and put into a contact sampler and into live. If you want to hear the whole project, the CD is on Bandcamp. And if you want to contact me by email, my address is on my website, and I will play a short part of the beginning of Fluid 2. Well, thanks for your attention. And
I will pass the word to Tarik, our second presenter. Tarik, I am a bit more familiar with because he's a visual guy, actually a very accomplished visual artist, and his approach I like very much because it's about creating a visual and sound using a single instrument, kind of an instrument that produces visuals and sound. And this is all done programmatically, which with Max, but using, I think, yeah, okay. Tarik will talk himself about this stuff. So yes, please, Tarik.
Yes. Hello. I'm Tarik indeed, and just a little introduction to where I am now and where I came from. I studied audio design, very much with the idea of being able to create music live in a way that would make sense to me. And even before I started to create, to study, I did have this idea that, so I had done some live performances where I could only turn knobs and add a little bit to the sounds of pre-composed stuff that I made. And I found this very unsatisfactory in that I knew that I was really providing anything truly meaningful to the performance. Sure, I was giving the people a human being to sort of like connect to the sounds that they were hearing, which actually is worth something. It's also about, just perception of the audience, but my perception was suffering in that I felt like a faker. So how was I gonna solve this? I thought of maybe having big red buttons on stage that I would maybe comically hit with a big hammer that would make sound effects, and I maybe would have a big steering wheel. And I was just having these kind of thoughts in sort of like a crude concept of what a meaningful live performance could be. How do I show the audience what it is that I'm doing on a stage? When I started studying it, I I didn't completely lose track of that concept, but I got fascinated with all the stuff that you could do with Max MSP and other forms of programming, because I did realize that programming probably was going to be my way to define my own ways of live interaction with the computer. Then I got very fascinated with Jitter, which is the visual part of Max MSP. And it wasn't with a very conscious goal in mind that I started fooling around with it. But in hindsight, I could definitely see how it connected with my initial goal of wanting to show people what I'm doing live on stage. There, like the word in itself already points to visualization. Often when the musician is on stage just playing the guitar, part of it is the fact that people can see them do it. So this whole audio visual thing I was getting very interested in. I started creating my own little sequencers. At first I made a two-dimensional sequencer where I could have notes horizontally and vertically placed next to each other, and I could play, basically could have playheads that would run horizontally back and forth, maybe at different speeds, maybe going up and down, maybe you run diagonally, all those kind of things, so that I could also visually see perhaps symmetries between bottom left and top right, or an inner layer of the melody and an outer layer of the melody. It was just really interesting to see what happened also to my musical brain as I was experiencing it visually in a different kind of a way. Then I went on to make a three-dimensional music system where I could basically fly in 3D past notes that I would place within the three-dimensional space. So basically I could perhaps see a melody in the distance, which is a bunch of objects, but I couldn't hear them yet because I wasn't close enough yet. But then once I would fly towards those objects, I could hear them in succession as I'm passing by them. And then maybe I would see something else flickering in the distance, and that would be a beat that I would not yet hear, but then I go towards that beat and I could hear that. So this was my whole exploration of audio and visual stuff. I then wrote to Robert Henke at some point, who was one of the co-creators also of Ableton Live, showed him my stuff, and he thought it was interesting what I was doing. He invited me to then do some visuals with a show that he was doing. So that was the first time that I'd used this whole system that I just now described, this three-dimensional system, which has visuals and sounds. I now use this purely as a visual tool. So I turned off the sounds and purely had some synchronization going on through MIDI with Robert's computer. And yeah, we did our first show in Glasgow. That was something that we both really enjoyed, and so we kept on doing that. And slowly during this whole process, I became more focused on the visual aspect of what I was doing. Still, to this day, very much also involved in the audio aspects of this whole three-dimensional system that I'm still working with. But also I got much more engaged in the purely visual aesthetics of it. And somehow that also connects to my father being a painter. So it is somewhere in my history that I sort of have this interest in all these different aspects. And I guess this sort of like this is coming from music into visuals, and all of it all the time being real-time based. This is a very defining factor of how I currently look at visuals, how I currently hear visuals. In that I find that this, at least in the way that I approach it, in the way that I experienced it, I find that visuals they are not always a part of the music, but it can definitely be part of the music. I'd like to use the term visual music for that, and I'm definitely not the first, but for me, I am one of the musicians when I'm making purely visuals and other people are making music. When I'm creating a visual context within which the sounds are being heard, I'm defining how the sounds are being heard. I think that's basically in the end where the sounds truly heard. It's not in the ears, it's in the brain. So it all goes into the brain, and then there's all these connections you're making inside your own experience. These might be connected to memories, these might be connected to associations that you have. of certain sounds to perhaps maybe little ants crawling around or something breaking or whatnot. All these things combine in the brain. So sound and music is never purely about sound or music. It's always about the whole context of your being, but of course also the whole context of your immediate surroundings, and the eyes are a very, very important factor in that. So yeah, for me that's the connection between visual and sonic music. Yeah, that's very much been my core of what I'm doing. Then what happened at some point was that the nice people of ShowSync, they connected me. These are Hidde and Matthijs, and by now they're a somewhat bigger group of people who created this software called VideoSync, which is basically a visual add-on to Ableton Live. So this allows people to create visuals directly from the Ableton Live interface, which of course completely connects to this whole way that I was dealing with sound and music anyway, in that sure, it's all different layers of the same bigger construct anyway. And for me, the main connecting fabric is time. So if you can work with visuals and musical time, and music and musical time, and you can perhaps also have the same types of instruments and effects and plugins living inside your Ableton Live sets. You can see lines of automation of visual effects combined, and right next to audio things. This connection becomes much more explicit, and you can play with it in a much more deliberate way that's also much more intuitive. So this very much appealed to me. It took me some time to really get into working with them as a full-time, I'm never completely full-time because I do a lot of stuff, but as a, in any case, a fully engaged participant. It took me some time to do that, but then COVID came around. I had no more performances to do with musicians and everything, and I could go way deeper into all the software aspects that I was doing, including also working with those guys from ShowSync and their product VideoSync. So now I'm fully engaged in working with that, and I'm gonna basically demonstrate some of what that means in practice. So I'm gonna share my screen and show a little bit of VideoSync. There are obviously a lot of other things that I could also demonstrate, but this is just the thing that I currently think is maybe most valuable in transferring the philosophies onto other people, because this is just a very hands-on way. And oh yeah, part of also what's this VideoSync, what makes VideoSync so valuable to me is that it allows people who are non-programmers but more perhaps purely interested in making music in more intuitive ways. It allows them to also make visual music in this intuitive way, which doesn't need or require any programming skills. So sharing my screen. Yeah, great. And so here we have VideoSync. Can everybody see this? Yes, cool. So here we have VideoSync and we have Ableton Live. I am now going to drop a video in here, just in my clip view. Let's see, VideoSync material. Normally within the clip view, you can't see videos. Ableton does have its own little video player that can appear when you drag a movie file in the arrange window. We do not make use of that. We make use of our own little window, which is this VideoSync application. As you can see, yeah, this is basically the VideoSync application. It doesn't have any proper GUI in itself, because all the interaction happens through Ableton. So it's a standalone, but it feels like it's just an output window for Ableton. So let me get the lip sync blue screen, drag it in here. Let's see.
Alcoholic rain will water Earth's soil with whiskey. Now perusing on freeways and theaters, we'll have lubricated petunias and lilies.
So everybody heard the sound and saw the visual? Cool. So yeah, this is just video sync in its most basic form. Just start it up, and it will immediately just connect with Ableton. You don't really have to do anything else except for drag a video in there, and it will play. So this is already a thing that's in which a way in which it expands what Ableton Live will normally do, because Ableton Live normally will only allow you to do this kind of stuff within the arrangements view. Here it can also work within the clips view, but it goes further than that. So let's try it again.
Alcoholic rain will water Earth's soil with whiskey, now perusing on freeways and features will have lubricated petunias and lilies.
So that's just already a very nice example. You can simply warp these things in any way that you want. And what I could also do is, let's get another one in here. Hiccup tester. Which is
alcoholic rain will water Earth's soil with whiskey. Now,
so yeah, now I have two videos playing at the same time. These are two tracks, and the audio slider, the volume slider, will define what the brightness is of each layer. You can also, by the way, define it such that the volume slider will not do that. So that the volume slider will be only for the volume and not for the visuals. All these things have been taken into account, but that's more detailed stuff. What I would also like to show is that if I group these two tracks, yeah, there's not much of a difference. These two tracks are still added on top of each other, but this is where I can add a little device called properties. It will define the properties of this visual track. And now defining that I do not want the blend mode to be additive, but I want it to multiply. Yes, exactly. So now we're basically multiplying. Let me turn this off. Exactly. So now we're going to multiply these pixel values of this white line with the pixel values of this man over here. So as you multiply basically what is all these ones with the original color, you get that this acts as a mask. The color white will just act as a pure mask. So now we get this.
Alcoholic rain will water Earth's soil with whiskey, now perusing.
And maybe, yeah. So what I'm going to show right now, yeah, there's all these other kind of blending modes that you can of course also do.
Alcohol.
Let's see.
Alcoholic rain will water Earth's soil with whiskey.
Well, there's a whole bunch of effects you can do there. The mute buttons will work. There's also also crossfading works as you would expect. And what's also pretty cool, which I will not demonstrate right now though. Of course, I'm not that experienced with it just yet. But what you can also do is you can use send and return tracks. You can actually send the video to a track over here, and then perhaps even and then create feedback loops within your visual domain. This is actually something that I could have practiced before. Next presentation, I'll do that because actually that's really, really cool. Because if you have feedback effects, you can get these Droste type effects. Basically, you can get an image inside an image inside an image, and then if you add perhaps some rotation, you can get these really cool flower-like patterns that emerge within that domain. Okay, so I'm going to delete this. Now I'm going to just add my an instrument in here. It's going to be the external in. I'm going to select device. Yes, cool. Here I am. I'm just going to show what happens with effects. I want to have the wavy effects. And I'm becoming a little bit wavy. Let's add some motion to this. Awesome. The scale I can change. And it can become fully abstract. And I can make it normal again. Actually, I want this image to not have the black lines on top of the bottom. So this external in device, I say change from scale to fit to scale to fill. No, that's better. So yeah, we have that. I can add some color. Changes on top of that. And what I can also do is, for instance, add this crop map device. Let me actually turn off these two effects. And this is a device that that was originally designed for just cropping an image. And then I thought, well, actually, it's nice if you don't necessarily have these super hard edges. What if we can can have this feathered to some degree? Well, that's really nice. You can have some more smooth cutouts. And then I also thought, well, what if I perhaps make the feather algorithm capable of feathering outwards? What could that look like? So that could look like something like this. And then other ideas came up, like what if you make that it doesn't crop, but it just tries to fit the whole image in there. And some algorithmical weirdness started popping up, and I thought, well, let's just keep it in there because that actually looks really cool. Because it's not necessarily, it's cool that this is a functional device, but very much the goal of video sync is also that people can just discover weirdnesses, stumble into accidents, and use them like very much a musician would do. At least I, as a musician, would often work like that. I just stumble into weird stuff that happens, and I think that's interesting, and then I just go with that, rather than to just have something that's purely functional. So this is both functional. It needs to completely, how do you call this, meet certain requirements. But then if it can expand those requirements through, for instance, having a feathering that can be both negative and positive, then great. So the perspective mode I also find really cool. So then basically just starts, you get this idea as if you're living inside an infinite universe of tiled versions of, in this case, myself. And then what does the feathering do? I thought, well, it's nice if the feathering could perhaps make, give the impression of a horizon. So this becomes even more of a 3D type thing, which can change in weird ways. And of course, if you do things that are kind of like nonsensical in the interface, you might also get semi-nonsensical results, but yeah, that can be fun. Yeah, and so the cool thing is that, of course, you can automate all these things. You can see here this cornerstone. I'm now all doing it by just dragging this 2D thing. These are all just parameters that you can automate, and then over time, of course, obviously, wouldn't surprise anybody that this can happen, and you can then, of course, play with that alongside the music in all kind of ways. Yeah, and what I like about this is that just like the process is often with music is I just loop things over and over again. I listen to the same bit, change something, and then again have a look at it, or have a listen to it, and then again, and then again. So I find that also really important in this musical approach of creating visuals, that you can do the same thing, that it's all real time. And of course, with computers these days being as powerful as they are, this is actually an option, super cool. So I want to make use of that. So just go back and forth over a piece of visual, listen to exactly to how it connects to the music. At some point defining, you know what, it's cool that this visual is doing this right now, but I want the curve, on this precise curve, to be slightly different. And it should hit maybe just a little bit before the beat hits, and not exactly at that time. And that's the kind of intuitive flow process that for me can only be achieved once I do not need to render things for 25 minutes, and then I can just really go be in this process, in this continuous process. Yeah. Okay. I'm now going to show basically, yeah. So we're very much in the process of making this tool. I think it's very cool already. You can go online, go to the ShowSync website, download VideoSync, and these tools that you now see are already fully usable. And yeah, you can make your visual music with that. So yeah, definitely go ahead and do that if you're interested. But what I'm also very excited about is about the fact that it is very much in a process of growth. Now that I'm also very much involved with it, and I'm deeply into the C++ code and all this, all the visual code. There are just so many ideas popping up, and we're currently developing lots of these ideas. I'm just super excited about that. So I'm right now going to show some of the stuff that is not yet out and is still very much under development. So what you're going to see here will perhaps never be available in exactly this form, but it is something that just shows the direction that we're working in. So now I'm going to add this experimental Voronoi effect on top of it, which is somewhere in between an effect and a generator, because what you're currently seeing is basically, you know, Voronoi plugin. Voronoi is the name of this type of texture that you're seeing. You can change the scale of it. You can make it wiggle. Let's have a wiggle on a different type of scale. That's all cool. But why am I still calling this an effect? That's because we can also define what the input image has as influence. Right now, for instance, I'm saying I'm going to turn up the color parameter. And you can see, maybe to some degree, that my movements are defining the color of this Voronoi pattern. If I'm now going to add brightness, you can see how this whole pattern is now very much informed by, by the webcam image. Basically, I'll just scale out a little bit more, then it becomes much more clear what's going on. So now I'm going to scale in a little bit. Yeah, so now it's clear. I'm going to make these things wiggle a little bit. Scale in a little bit more. Oh, more like this. Maybe use the original color, but the brightness of the webcam image, or the other way around. I'm gonna say no brightness influence, but only the color. Yeah, and then what I think is also cool to show is yeah, let's do a little like this, a little less motion. Yeah, now I'm becoming a little bit of a Picasso type creature. Yes, there we are. Yeah, and now I'm really being hustled in a weird way. There's all these other parameters with which you can define precisely what you want this thing to look like. Yeah. I can make nice little pebbles as well. So this has been a lot of fun. Let's switch this thing off again. This has been a lot of fun trying to, not trying to, but actually designing these devices. It's been very interesting in that I'm noticing that there's a very big difference between designing this. Oh, by the way, how much overtime am I? I have no idea how long I'm speaking.
It's really some time, but you can just go on, finish.
Okay.
Sure.
Yeah, okay, that's okay. So so I'm nearing the end. Okay, so just quickly, what I found very interesting in this process was that there's a very big difference between designing an instrument or effect for myself versus doing that for somebody else. In that when I'm doing something for myself, it's a very direct process of, okay, I have an idea, something that I want to achieve. I make a device that achieves that, and that's great. I have some parameters that define what I can do with it, but as long as it does what I want it to do, that's fine. But for instance, with this Voronoi device, it's been very interesting. So what are the parameters of what I wanted to do? If, for instance, I have this kind of a let's see. For For instance, I as an individual artist, could be super happy with just this effect. This is exactly what I want to use. But then I place myself in the mind of a user, and I could easily see, well, of course, this user then sees these boundaries of this very specific width. It would be very natural for them to get frustrated with the fact that they can't then change the width of these boundaries. So obviously they want to have that. And so there's been this whole process of what are the possibilities I'm giving a user, but then also what are the frustrations or the expectations that come with the possibilities I'm giving a user. You can give somebody something, but if you give something and don't give it enough forethought, you can actually give them a lot of frustrations on top of that, because users are not always happy with what you give them. You're basically, it can feel to a user like you're giving them an unfulfilled promise. Like, yeah, you gave them a finger, but obviously they know that theoretically there's a whole hand attached to it. So yeah, take my hand and I will give you a hand. If this sort of like a metaphor makes sense. Okay, then just zum Schluss, I'll give one other little thing that I'm working on, which I find really cool. This is a similar type of texture generator / effect. Here we have another thing, similar idea. You can scale it up and down. There's different effects over here, different articles, ways in which you can change the nature of the texture. And also here I can define that I want this to be instructed by the webcam image. You can now see that my color, my brown skin color is moving across this surface. And I'm going to now add the brightness to it. Yeah, you can now see how this is changing. I'm again also going to make this move a little bit. Let's have some motion. Yeah. And again, as I zoom out, you can see how my face emerges here. Yes, exactly, like this. And scale back down again. And here we are. Obviously, all this stuff can be combined together, so I'm just going to add, as a last little thingy, the crop map on top of this, and we're going to have all this stuff tiled in an infinite space. And I guess that's gives a little bit of an impression of the path we are following here. There's obviously much more to say, but I won't say it right now. I think this gives a little bit of an idea. And so thank you for your attention.
Thank you very much, Tarik. This was great. I always wanted to understand how video sync works, and now I finally have an idea. What I find crazy is how it seamlessly works with Ableton. Just plug and play, and just everything is directly connected. And I know there is a big work behind this to work in such a way. Great, cool. Thank you very much.
Yes, you're very, very welcome. I just now need to figure out how to stop sharing my screen.
I think there is this icon on the bottom.
Yeah, I got it. Stop share. Awesome. Yeah.
All right.
Yeah, but yeah, it's been indeed a huge effort by Hidde and Matthijs, the two other main programmers. There's also a bunch of other people doing super valuable stuff right now, but those are the two who came up with the main concepts of also how to make it so seamlessly. At some point, you just don't even think about it anymore. That's a different program, and that's really due to they made a lot of efforts to make sure that you basically don't feel the effort anymore, which is amazing. Yeah.
Cool. Okay. And now to Matteo, which is the person I'm mostly familiar with. Matteo is a colleague of mine at cycling, and is actually a jitter genius, a visual genius. I don't want to embarrass him with praises.
Well, you are.
Too late for that, I guess. Yeah, I'm a big fan of Matteo works, and yeah, and now I give him the word.
Thanks, Fede. Thanks so much. So for today, there wasn't really a topic, so I went pretty much freestyle, and I decided to talk about something that I love pretty much, that is procedural drawing. I don't know if you are familiar with procedural art in general, also sometimes called generative art. but I'm a big fan of that. And I want today to show you something you can do with Max to start diving deep in that direction. So I'm going to share my screen. Okay. Save, don't save. That's the dilemma. Save. Okay. Cool. So I want to start from a blank page because I want to show you a way to start building a procedural drawing patch in Max. So there are several ways to do that, but something I like to do is to use OpenGL objects to draw something on screen. So in order to make those work, as you know, you should reach for a JIT-word object. But since I want to draw something in 2D, there's something else I need to add. Usually what I like to do is to set here the attribute at ortho 2. So ortho means orthographic. By setting it to the value 2, it means that it won't consider perspective anymore, but rather objects will not tend to converge to a focal point with the distance. And this is precious because we can simply now ignore the third dimension and simply consider this window as a sort of canvas where we can identify each part of it as -1, 1 for the x coordinate and -1, 1 for the y. So that's pretty convenient. Then, in order to draw something, as we said, we need to use a GGL something, and for example, a GGL mesh. And one way to create a procedural drawing is to, well, first, maybe I should explain what is a procedural drawing. That would make sense. In general, when I say procedural drawing, I mean that I want to create a drawing where I'm not bothering about the final result, but rather, so I'm not drawing it in the traditional sense, but rather I'm building a procedure, a method, so an algorithm. So what I'm going to do is to set up some rules that make sense, and from this rule, from this set of rules, the final picture will emerge somehow. So to make this happen, a possible approach is through the so-called accumulation. So you draw something, you iterate again through the set of rules, and you draw the next result, then the next, and so on. So we need a way to accumulate what this GGL mesh object is supposed to draw. And to do so, what I like to do is to use a GGL node object with the attribute @capture1. So to capture the result of this GGL mesh into a texture. This lets us do something very cool, which is video feedback. So if we take a GGL pix object, for example, we take this texture, which represents the result of the current frame, and we can sum to it through this operator the history, so what we already drawn. And what is missing is to connect this sum to this second inlet. But as you can see, we cannot do that directly. So we need to use another GGL pix where we can simply plug the input to the output. And that's it. That's mandatory for creating a feedback loop. So this is the basic setup. From here will come out the result of this accumulation process. So it works exactly like with audio. Here I'm using a sum to combine the current frame and the history, but you can use whatever you want. You can alpha blend the two images. You can use a maximum operator to take the brightest of the two, and so on. So you just have to experiment. But that said, I'm not even going to save this patch because all the patches I'm going to show you contain this sort of architecture, rely on this. So instead, the first thing I want to show you is a hopefully working example of procedural drawing. Let's start from this one. Okay, so it's a pretty simple and compact patch. It implements this kind of process that you can also replicate with just a pencil and paper. Imagine you draw a vertical line and then you move close to it, to its right, and you draw another vertical line, trying to follow what you drawn before. Of course, no one can draw a perfectly vertical line, so some errors will be introduced. So the lines will contain some, I don't know, jitter. Then you move on, you go one step to the right again, and you try to mimic the last line you draw. This way, the error keeps accumulating, and eventually, by the end of the process, or after enough iterations, the result will be very much different from a straight vertical line. So here I can start the process, and slowly, the first line was perfectly vertical, but now I keep accumulating this error. And eventually, by the end of the process, which I can identify as the end of the canvas, this line will be pretty much different from where we started. Here you can also play with some parameters like the distance, the fixed distance between the lines, or the amount of error we are introducing. You can also go crazy with this one. So this is a very, very simple process, but it works. You can create a cover for an album if you want. And by the way, all these patches, I'm going to send those to you via, I guess, I don't know, maybe Google. I don't know. Anyway, I'll give you a link. This very same process can also be achieved following a different shape. So for example, this patch does exactly the same thing, but instead of drawing vertical lines, it starts from a circle and then expands it, increasing the radius and still trying to imitate the latest circle that was drawn. Not to waste your time, I can show you some results I already rendered. Let me take those. No, not this one. Okay. So nothing fancy, but these are some possible outcomes. Here with a small amount of noise, here with definitely more noise of light. Okay, so this is a very, very simple way to create a procedural drawing. The rules are very simple. Just imitate whatever you already drawn. But of course, the rules can be pretty much complex and things can escalate a lot. So I'm going to show you another patch. This one. Okay. First, I show you how it looks like, and then I try to explain you how it works. Okay. So as you can see, I started drawing a bunch of lines, all going in this direction. What happens is that I defined a boundary for this canvas, that is this sort of circle. And every time a line reaches the boundary, what happens is that the line stops. Then we compute the middle point between the start and the end, and we start drawing again from there with a 90-degree shift, left or right, randomly. And this is not the only condition. Every time a line meets something, so another line, it does the same. It stops, compute the medium point along the line, and start drawing again from there. So this is pretty simple rule again, but from a simple rule can emerge a very complex behavior. And one thing I like very much about procedural drawing, and in general, the procedural approach also to music, to 3D modeling, whatever, is that a simple change of the initial conditions or the rules may lead to very different results. So for example, let me show you some different outcomes using the same patch. Okay, I have the zoom bar right on the Finder. Okay, so where is it? Okay, like this one is pretty much the same, just without the circle around. This one, I started all the lines closer to the center, and this kind of pattern emerges. Or for example, here, all the lines were started at randomly somewhere, but all pointed towards the center. Here, I reiterated the process multiple times. So once the drawing was finished, again, I created new lines, and this is the result. Or I don't know, here I grouped some origins for these lines. Or yeah, this is another one. This one looks sort of like a city, something like that. So starting groups of lines in different directions. So all the drawings are pretty much different, but the rule is always the same. Here, starting from the border. Here, for example, I tried not to start from the middle point, but rather to start from the line left. And this kind of pattern emerges. And this is the same thing, but instead of turning left or right by 90 degrees, each line just takes a new random direction. So this is another example. Somehow it requires a sort of knowledge, of awareness of the environment this time, because each line must consider what is already there in the final picture. So it's a bit more complex, but the patch itself is just very few objects. Everything happens inside this GGen, inside here. And I think I'll also leave you maybe a more commented version of this patch to make it hopefully clearer. And then something else I want to show you is a way to use this procedural approach, not to generate from the scratch some images, but rather to process some existing images. So let me reach for another patch. Okay, this one. All right, so here the rules are pretty simple. I take an image, I convert it in black and white, and then I take a particle, if you want. I drop that particle inside the image. Now, this particle lands somewhere in the image. I read the color in correspondence of that pixel. That color, being a black and white image, is represented by a value that may range from 0 to 1. What I do is to interpret this 0 to 1 value as an angle. So I multiply that by 2 pi, so to have a direction. Once I do that, I move from there one step in the direction that I just computed this way. This way, the point, the position is shifted, and the point lands on another pixel. And here we do the same. Take the color, convert that into an angle, and move on. Move on, move on, move on, and move on. But every time we take these steps, we connect all these positions using some lines. And frame after frame, we keep accumulating using the same approach. So always with this loop, we keep accumulating all these short segments. And of course, I'm not going to use just one single point, but rather a lot. Yeah, a lot of points. So let's make some examples. Here I take an image. Okay, like this one, for example. So open it. Okay, got converted in black and white. Here I'm dropping 300 particles on the image. And then we start the process. Now, slowly, you should see something emerge. What happens is
Matteo, I think, got frozen. Hopefully we didn't lose him forever, since he's outdoor. Maybe the pub cut his internet in the end. Okay, while we wait that Matteo comes back here, this great stuff really remind me of this book. Oh, now it's gone. It's called Generative Art from Matteo, not from Matteo, Matt Pearson. And if you are interested in this kind of generative stuff, it's very simple things. It's not like stuff that Matteo is showing, but it's kind of a nice introduction to the subject. Just came to my mind seeing Matteo's stuff, which is really cool. I was really curious to see this last one. Hopefully, or not sure what was the last, but surely this looked pretty promising. Let's see if we can get him back.
I guess if anyone's got any questions, now is maybe a good time if we're waiting for a bit.
Shall we just go with questions to Tarik and Arthur? I'm just afraid that if we go into the breakout rooms and Matteo come back, then will be a bit difficult to take everybody back. Or we just make open questions without going to the breakout rooms, maybe. Cool. Okay, yeah, then let's go for it.
I've got a question for Tarik. So is there quite a lot of shaders going on under the hood in VideoSync?
Yeah, absolutely. It's all shader based. Yeah. Yeah.
We got Matteo back. Sorry, guys.
Hey, guys, sorry. I don't know what happened.
The pub cut your internet.
Yeah. Can you hear me well?
Yes. Yeah,
Okay.
if you want to go on, that would be cool.
Yeah, sure. So I share my screen again. All right. So I don't know where I left Zoom, but it was slowly generating this kind of drawing. So it's pretty dark. Probably I should increase a bit or better reduce the transparency for these lines. Well, let's do that very quickly. We just need to change this value and start again the process. So anyway, here we have all these particles moving on this image and leaving some trails. But of course, you can play with some of these parameters. For example, here I'm taking these values that range from 0 to 1, as we said before, but we can decide that 0 to 1 is remapped to, I don't know, 6 full rotations, for example. So doing something like that, the result should be different, as the particles are more likely to change direction. And also here, I have this filter that is filtering the angle. So let's say that the particle is moving in this direction for a while, and all of a sudden, the color tells it to turn left. Using this filter, you can smooth out this turn. So you can make it rotate slower. But if you set that close to the value 0, like 0.1, we should have, well, you can see that we have some particles moving. You can see that the drawing becomes more detailed. I start the process again. Okay. So this is the concept of the flow field, if you are familiar with this kind of drawing, only applied to images. And again, you can, for example, with this patch, I don't know, change the overlaying image while the process is running. So we should get, yeah, like this, something emerging from where we left. So you can stack multiple images, one on top of the other, or you can play with these parameters while the image is generated. So you can, I don't know, increase this rotation angle even more, or reduce that so that they should almost go only in this direction, and so on. Once you are satisfied with the result, you can simply stop the rendering and, for example, connect the JIT matrix like this, give this JIT word a bang, and then export the image. And you just save that wherever you want. And again, let me show you some examples that I got used, some results that I got using this patch. Oh yeah, these examples. These, for example, are images that I got processing the result of the previous process. So the previous patch you saw, I just took those and plug those inside this other process to see what, I don't know, what they could look like, and they're pretty good. So those are very simple processes, but as you can see, the result is very, very complex. And this is what I really like about this approach, so procedural drawing. And all these patches I want to send you, yeah, I don't know, maybe on Google Drive. Yeah, maybe that's the best option. I'll leave you a Google Drive link. Now I prepare all the files and leave you the link in the chat or under the YouTube video. And that's it.